Hello, good morning, friends. In today's physics class, we will learn a little about dimensions. Now, what exactly is the meaning of dimensions, which I'm going to tell today, is see, we have been using this word dimensions for long, and we know that the dimensions can be one dimension, two dimension, and three dimension. It means that if you want to express the motion which is taking place in a straight line only, like we have been using the number line in mathematics. So what was that? That was one dimensional display in which we need only one axis for the description. Okay. Then we had learned graphs in mathematics, which required two scales perpendicular to each other, that were x-axis and y-axis. Now that was two-dimensional expression. Okay. Now coming to three-dimensional expressions, we see that the world around us, if you see any object, you can see its height, you can see its width, and you can see the distance of that object from your eyes. So actually, to see it, you need three axes, that is x-axis, it's like this, then y-axis, which is vertical, and z-axis also, which is coming out, in and out like this. Okay, so that is three dimension. Okay, but what today I'm talking about is not these 1, 2, 3 dimensions, but it is actually the dimensions from which our universe is made up of. Now, if you analyze the universe, you will find that it is made up of two things. These two things are time and space. According to physics, the universe is made up of only these two things. One is time and the other is space. And if we go for a more deep analysis, we will find that even this time and space, they are also made up of few more things, which we can say that our entire universe is made up of three things rather than two, three things. These three things are mass, length, and time. Now, what exactly is the mass? What do you mean by the word mass? Roughly, I can tell you, see, there are exact definitions also, but to understand what is mass, the explanation, the simplest explanation of mass is that it is the total amount of matter that is contained in a body, which is known as mass of the body. Okay, then the second thing is length. Now, what is length? Length is the spacing between 2 points, the gap between 2 points. This is point P1, call it point P2, and this thing. Okay, the space between these 2 points is known as what? It is known as length. Okay, and the last thing, time. What is time? Time is, you can roughly say, it is the spacing between two events, or it is the gap between two events. Some event occurred in 1960, some event occurred in 2020, so there is a time lag of about 60 years between them. So what happens between them? Whatever happens between them, we call it as time. Now, there are more than these three things in this universe actually. In the beginning of physics, we discovered only these three things, that universe is made up of mass, length, time, and nothing else. But later on, some more things were discovered. Okay, the universe is also made up of something which was known as electric charge. Plus, it was discovered that it is known as it is made of thermodynamic temperature also. Plus, it was also noticed that the quantity of matter can also be given in terms of moles, or there are many other things like that. But right now, for the syllabus of class 11th, these three things will be more than sufficient, because now if I include this charge and thermodynamic temperature and mole, then it will unnecessarily make the things complicated. So we are not going into the other ones right now. We are concentrating only on these things: mass, length, and time. Okay, so these are what we call as the dimensions: mass, length, and time. Coming to the next thing, after dimensions, is the dimensional analysis. What is dimensional analysis now? See, we have been studying physical quantities like speed, velocity, acceleration, time, pressure, density, electric current, resistance. What are all these? These are physical quantities. Okay. Now, if the entire universe is made up of these three things only, mass, length, and time, that means every other physical quantity is also made up of these or a combination of these. So, analyzing that what thing is actually made up of what, that process is known as dimensional analysis. Okay. So, what do we actually do in dimensional analysis? Once again, I would like to repeat what is dimensional analysis. Any physical quantity is made up of only three things: mass, length, time, and their combinations. So, how these three things combine to form a physical quantity, this analysis is known as dimensional analysis. Now we go for the very first physical quantity, which is mass itself. Okay, now how to analyze, how to find out that what exactly mass is made up of? So mass can be made up of mass, could be made up of length, could be made up of time. Okay, but we know that mass is simply made up of mass. It's not made up of length. Length cannot contribute to mass. So we took this, we hail L to the power 0. Now time. Time again cannot contribute to make a mass. So time also does not play any role in mass. Definitely mass is playing a role in making up of mass. So we give it the power 1. Okay, and once we put it in square bracket, we now can say that this is what? This is the dimensional analysis or dimensional expression of mass. Similarly, for the other two physical quantities also, I can write the dimensional expressions. See, the dimensional analysis, dimensional expression for length. It's only length which contributes to make up of length. Mass has no role, so the power is 0. Time has no role, so again the power is 0. So this is dimensional expression for length. Similarly, this is dimensional expression for time. Time has a contribution. Length does not contribute to time. Mass does not contribute to time, which means if length changes, the time may change or may not change. If mass changes, time may change or may not change. They are independent of each other, so their powers are 0. Now these three physical quantities, mass, length, and time, because they make up all the other physical quantities including themselves, they are known as fundamental physical quantities. We call them fundamental physical quantities. Okay, there are other quantities also, such as speed. Speed is also a physical quantity, but it is not a fundamental physical quantity because it is not one of the basics of the universe. Now, if I want to analyze that, what speed is exactly made up of, means I want to dissect speed. I just want to know that how speed is made up of mass or length or time or whatever. So the process of this thing is known as dimensional analysis. Let us see how do we find out. We should first know the formula for speed. That is, speed is equals to distance over time. Okay, what is distance? Distance is actually a kind of length, and time is nothing but time. Okay, now what is length? Can you tell me what are dimensions of length? It's given over here. M0, L1, T0. Now what are dimensions of time? Time again has these dimensions, M0, L0, T1. And now if I algebraically deal with this fraction, what I finally get is M0, L1. T is in the denominator, so T becomes -1. So this is how mass, length and time are physically contributing to make this new physical quantity called as speed. Let us also analyze one more physical quantity, which is volume. Now the basic formula for volume is what? Length into width into height. What is length? Length is M0, L1, T0. What is width? Width is again a kind of length. Okay, if you measure it vertically, you call it length. If you measure it horizontally, you call it width. So basically, what is width? Width is again a kind of length. So height is what? Again, see, height is also a kind of length, measure in some other dimension. Now we mathematically deal with all this, and what do we get is M0, L3, T0. These are the dimensions of what? These are dimensions of volume. Similarly, the dimensions of area, very simple. The formula of area, length into width, length into length, M0, L2, T0. If you understood how I designed the dimensional expression for volume, dimensional expression for area, it again becomes very easy to understand. Okay, let us take example of one more physical quantity, that is density. Now the basic formula you should know, that is density is mass divided by volume. Now let us write the dimensions of mass and volume. M1, L0, T0, the dimensions of mass. M0, L3, T0, the dimensions of volume. And when I mathematically simplify this, this is what I get. The dimensions of density, M1, L-3, T0. So, in this way, we can find out that how the other physical quantities can be known, that what's the contribution of mass and length and time in making those physical quantities. But one thing, for dimensional analysis of any physical quantity, we should know the formula of that physical quantity, because only in the formula these substitutions can be made and dimensional analysis can be done. And remember one more thing, that whenever you are writing the final dimensional equation for anything, you should always put it in the square brackets. Okay.